Okay, everyone, it's 11 o'clock, so we'll make a start. So thank you very much for being with us today, once again in the session. So we'll make a start, yes. So hopefully today we have the session set for 1 hour, but it may not take as long as that, but we certainly will have time for questions along the way, well, more particularly at the end, should I say. Some of my colleagues will be looking at the chat messages. I can't see them directly when I'm presenting. We'll certainly look at your questions. Please do put them in to the chat as we go along. So what are we going to talk about today? Well, first of all, but before we get to that, let me introduce myself. My name's Stephen Doherty. I am the RIQAS technical expert here in Randox. We have been involved with providing EQA services on a global scale for the past 34 years, of which I've been involved for 32 of them. So I've been here a long time, and I've seen lots of changes with EQA throughout the years. And certainly frequency and how frequent we should run EQA is definitely one of those areas for EQA where there's still a big difference. And what I want to talk about today, once we look at then the actual running of our EQA, just I can move on to the next slide. There we go. Yeah, whenever we talk about how frequently you should run EQA, there's still big differences between the various EQA schemes out there. So really what I want to do today is just have some insight into what we believe as an EQA provider, how frequently you should run your EQA, and also look at some of the benefits of running a more frequent. I'll say it out from the very start. We certainly believe that the more frequent the EQA, the better. But we'll hopefully be able to see some of those details as we go through the session today and why we believe that. So we'll start first of all by looking at a survey. This was performed by the IFCC Task Force on Global Laboratory Quality. And basically, it was a survey of full and affiliate members, 110 in total, and they saw a response of about 37% of countries representing all of the IFCC regions, all apart from North America. Now, we'll come back to that later and we'll talk about that. But these are the responses about EQA availability and practices. And as you can see, even within these 41 countries, there is a big difference in the EQA scheme provision with regards to frequency, with the major one being monthly. But as you can see, every 3 months, every 4 months, 6 months, and even annually do come in. So there are lots of EQA schemes out there, all running at different frequencies. Why would monthly or even more frequent be better? So that's one of the things I'm going to talk about today. So let's look at some of the considerations for the lab when choosing our EQA. And if we start at the very beginning, so does a scheme provide the tests? Well, first of all, that's going to be your primary concern when choosing an EQA scheme. Does it actually provide the test that you need? And we have to remember that the EQA schemes out there cover a wide range of practices. They're covering a wide range of different, chemistry, immunoassay, down to other pathology tests. So they're not all going to obviously provide, each EQA scheme is going to be different. And in some cases, as we move around looking at the suitability of the test items, the homogeneity, the stability, the concentration, that will have an impact, once again, even on the frequency of the scheme, because some test items may not be available. Then moving around to the organizational logistics, the timing, location, sample stability considerations, and even the distribution arrangements, this will once again have an impact on potentially on the frequency of the EQA scheme, as will the scheme design. Basically then looking at the procedures for establishment of your assigned values, the statistical treatment of data. This will have an impact on looking at the number of samples that are provided, whether they cover multiple concentrations at one time, whether samples are repeated through an EQA cycle. So the statistical treatment of the data will play an aspect there, and of course how reports are presented. Obviously, we're going to look at whether there's going to be a regulatory requirement as well. Is the EQA scheme required for regulatory purposes or not? What we tend to find is a lot of the regulatory type EQA schemes are less frequent. They're there to serve a specific function, which is just a quality check on the individual EQA labs. They're not really designed to help the labs improve performance and as part of the QC strategy. So a different type of EQA scheme. And we have to really keep in mind what is the main function of why we're running EQA as part of our QC strategy. Is it just for regulatory purposes, or is it going to provide us with additional information and to assist us in our QC strategy? So, well, I mentioned, of course, here then frequency of samples provided. Well, the frequency, of course, there will be EQA schemes which will offer multiple different frequencies. So even for the likes of ourselves, we have the same parameters being offered in multiple frequencies, bi-weekly and monthly as one of those. So which is best, even within the EQA scheme, which is exactly the same material, but providing it at a more frequent analysis? Does that actually offer us more than what we get with a less frequent? The timescale of reporting results and analysis of data, this we'll see as we go through our presentation today. This is important. Not only the frequency of our EQA, but then how quickly we get the reports back to you. And that is, we'll look at that as we go through the session. Overarching, one of our main concerns, of course, is the cost of the EQA. But we need to really keep in mind, is it fit for purpose? We may go for a cheaper option, we may go for a less frequent option, but does that actually provide us with what we require? Unless it's a regulatory scheme, and it's one of these that you have to run. But if it's not a regulatory for regulatory purposes, then what we need to ask, is a less frequent EQA scheme actually fit for purpose? And this is where then we're going to look as well as one of the other main reasons why we're running EQA is, of course, accreditation. And we're looking for that for our accreditation purposes. So we're going to then quickly move on and talk about the accreditation. So, apologies. Right, this didn't quite work the way I wanted it to, but there we go. That's all the ones that we're saying. So we're going to look at ISO guidelines and EQA. And what does the actual accreditation bodies require from EQA? And even then looking at the frequency of EQA, what does it actually mention, if anything? Now, I'm going to discuss the 15189 here, the international standards, and focus more on the 2022 and the latest actual version of that. Now, we do realize that depending where you are globally, that your requirements for accreditation may be different, but we'll look at the international standards because this tends to be what even the local guidelines are based on. So let's see, what does it actually mention? Well, first of all, what clause are we looking at? Well, it's the 7.3 examination process, and more specifically then 7.3.7, ensuring the validity of our examination results. So obviously that is what we're looking for here with not only our internal QC and our EQA. Our internal QC, looking to monitor the ongoing validity of our results. Okay, that's verifying the attainment of our intended quality. But it just doesn't end there. We obviously need EQA as well. And what are we doing for our EQA? We're monitoring our performance by comparing with results of other laboratories. Okay, so we need both. Why do we need both? I'm going to spend some time on talking about the need for EQA because this is an important aspect when we look at then frequency and when we're looking at how valid is the EQA scheme. Does it actually perform what we need? So we asked the question initially, why is internal quality control insufficient by itself? The clause is mentioned there by you're looking to monitor your performance by comparison with results of other laboratories. But as we know, any measurement that we make, we will have imprecision in that measurement. There will be random error causing variability of our results. And we can measure a sample time and time again, and we will then, of course, get a mean. We will then have a range of results, and we'll see what our imprecision is based on that. But that does not mean that that is the true or correct result. So we need to take bias into consideration because one, as we know, inward facing, we're looking at our own internal performance. External, we're looking at this comparison. How do we have, using our same setup of our instrument, our reagents, our calibration, is that the same as other users with the same setup? Remember, the calibrator is the link here to your primary reference material. So this is really what we're saying is this calibrator that we're using, is the setup that we have going to give us the same, basically the same result as this other labs using the same setup as ourselves. So that's why we do the external comparison. We look at total error because we have the combination of both. And when I talk about total error here, I mean the total analytical error. Any measurement we make will have both aspects, imprecision and inaccuracy. It's the combination of both these random and systematic errors. The 1.96, this is our coverage factor, which basically looks at that distribution of results that we have through our imprecision. And with this, we're saying we're 95% confident that our results will fall within a certain range. But that is separate to the bias. And what I want to talk about very briefly now is the importance of that. So first of all, we have an example here. This is a lab that we've seen through our RIQAS, a lab with poor precision. And as you can see, over time, you've got lots of failures that fall outside of our ranges, but yet their average performance is okay. As you can see with the line here with the open circles, this is their average performance. But from any individual sample, it's up, it's down, we don't know. It's got poor precision here. So if you think about this, if you're running an infrequent EQA scheme and you were taking a snapshot of your performance, what would it be? Would it be one of the samples which is in, or would it be one of the samples which is out? So here we have between three samples. I'm not sure if you can see my mouse pointing here, but sample 6, sample 7, and sample 8, right in the middle of the screen. 6, you've got a large negative bias. 7, within the actual performance limits, and then sample 8, a large positive bias. So as you can imagine, if you're taking a snapshot of performance, what is your performance? Is it negative? Is it positive? Is it okay? You need regular assessment to be able to see this variability building up over time. So this is one, first of all, that we're looking at the importance of EQA and having this regular check rather than a snapshot sort of assessment. Next, I'm going to look at then the importance of EQA when we look at our QC strategy. And we look at the probability of results falling outside of our total allowable error. So if we look at the top example here, if we have a lab with a CV for an individual parameter with a CV of about 3%, and say for this parameter they had a total allowable error of 10%. In this case, under stable conditions, then one result in every roughly 1,100 situations would fall outside of that total allowable error. However, if we had a bias with a 6% shift, which is indicated here by the solid line, then in this case, we have almost 10% of our measurements will now fall outside of our total allowable error. So as you can see, it makes a big difference. Having this shift in performance, we can have a significant increase in the probability of results, even under then stable conditions. If we have a bias, this will dramatically increase the potential for results that will fall outside of our total allowable error. How do we improve this? Well, in the second, if we look at the example down below, in this case here, we've just improved our CV by 1%. In this case here, under stable conditions, we've now moved from one result in about 1,150 to one result in 1.7 million, falling outside of our total allowable error. So you can see, okay, even improving our precision has had a dramatic effect. What about the bias? Once again, if we have a bias in this same situation, we've moved now from 9.7% results falling outside of our total allowable error to about 2.3% outside of our total allowable error. So that's still a significant number when we think about the potential thousands of results that we're dealing with on a daily basis. So trying to indicate here, we need both. We need to look at precision and we need to look at bias, but bias does play an important part, and it has an important part to play. It, of course, is important around our clinical cutoff points. If we have a bias, then we can see that we will dramatically then increase or potentially then decrease then the actual amount of results which are falling above or below the clinical cutoff point. So this will play an important aspect as well when we look at frequency and we look at the importance of how running a frequent EQA scheme. It really depends on your QC strategy. It depends on the parameter. It depends on the clinical significance that we have if we get this wrong. So keep that in mind as we move forward. So I'm not going to go through a whole lot here about IQC. This isn't for this session, but one of the things I want just to mention is two situations here with calibration. So your IQC doesn't address your calibration issues, your instrument systematic errors, using wide acceptable limits, and then control over the full clinical range. And often it doesn't encompass the entire testing process as well. Once we start to look at some of our point of care systems that we have, it may not encompass that entire process. But I want to concentrate just very briefly on the calibration issues. And I'll just move on to the next slide. So first case study. In this case here, we were looking at lithium, and this is an example that we've seen on RIQAS, where we've had, in this case, an instrument manufacturer for lithium that really didn't compare at all to the other chemistries. As you can see, it's out by itself. And in this case, once again, the internal QC would look very much acceptable, but there's no standardization compared to the other chemistries available on the market. In this case, we ran our own study, and we ran by 50 patient samples. We did by measurement by flame photometry, which was the reference method for lithium. And in this case, as you can see, it was also run on the VTROS system, where this is the example from. And it showed a 0.1 millimolar positive bias. We reported this back to the manufacturer, and we worked together, and the manufacturer then adjusted their calibration values downwards over 2 lots or 2 generations of material. And as you can see, then the performance improved. So once again, calibration, you can't look at this internal QC in itself as insufficient. You would not see this sort of situation then if you're only looking at your internals. Case study 2, this is a bimodal distribution for testosterone. And in this case, we can see where we started to see, in this example, a spread of results on a bimodal distribution. So over time, and we started this investigation, and we found out that a new kit had been brought out, which was giving much lower results. So the manufacturer was re-standardizing their kit. Why? So why were they re-standardizing? Well, this is a regular occurrence. We have found, and we often see this, where manufacturers are constantly looking at improving their methods, improving their performance, and also looking at standardization. And this is one of the main functions as well of external quality assessments. It's looking at standardization of methods. Over time, we can see where this has then improved, and all users have moved to this new kit. So what has this got to do with frequency then? You may ask, well, why am I mentioning this? Well, you can imagine then if you are once again running an infrequent EQA scheme, and you're in the middle of this change, you just don't know what you're going to get performance, potentially maybe because you're in the new kit or you're part of the old kit, and you're not going to know exactly where you are. Having regular checks and seeing the shift of performance over time on this, because you can see this general movement, it's so much easier then for your troubleshooting. And whenever you do run your EQA, then you know the reasons, okay? You know you're going to shift down and be part of this new group then over time if you're using the old one. So it gives you a clearer picture of your performance, and it does provide easier troubleshooting. Okay, let's jump back to our ISO guidelines and then look at not only so that was the requirement for EQA, but what about then some of the other clauses with regards to EQA? Well, first of all, we see here the sample should be processed by personnel who routinely perform the various aspects of the examination process. So you can imagine if you're running an infrequent EQA scheme, how are these personnel going to get involved in running the actual samples? It's going to be much more difficult. Depending on the type of EQA scheme that's out there and the reason why you're running your EQA, then as well as this, you're going, and this, I suppose this is one of the main aspects why a lot of, or why this clause has been introduced in the first place. Because previously, infrequent EQA schemes, if you're running it for regulatory type processes, obviously you need to get it right and you need to pass. So there's been a lot more emphasis on ensuring that this individual EQA sample, that we took special precautions over it. We had the most dedicated people testing it so that we passed. But that doesn't give us a clear indication of the performance of the lab. So this has been added in to the clause and into the standard. So because it forces then ourselves in the laboratories to basically really think about the processes that we're actually doing. So we want to have everybody involved because it gives us a clear indication of overall performance. Next, we're going to look at then this clause here, which is that the EQA data needs to be reviewed at regular intervals. Okay, I've highlighted just at the bottom the main part of it. It's a meaningful indication of current performance. And this straight away, then you need to look at your EQA frequency. Does the EQA scheme that you're running give you a meaningful indication of current performance? Okay, if you're running it twice a year, what's happening with your EQ, with your performance over all that time span between the running your EQA samples? So this, if there's one part of the clause that relates to frequency, this is it. It has to give a meaningful indication of current performance. And this is one way why you really need to look at your QC strategy and does it actually then give you this information? Why is that important? Well, the clause goes on to discuss this. So where EQA results fall outside your criteria, you're going to look at doing an assessment of whether that non-conformance is clinically significant as it relates to patient samples. And if it is clinically significant, then what do we need to do? The same as with your internal QC, we need to review our patient results that could have been affected, and the need for amendment shall be considered. So there you go. So you can just imagine, once again, if you're running an infrequent EQA scheme and you have a failure that is clinically significant, how many patient samples potentially have been affected in between running your EQA? So, and a very important aspect here, and it can't be overemphasized. So running infrequent EQA will not help us with regards to this clause. Okay, so really do need to keep this in mind. So the EQA provider, that's us, and others out there need to provide and return analysis in prompt fashion in order to minimize the impact of that potential poor performance. And as well as that, the lab, the participant, needs to review and take action likewise. So one of the main reasons why we want to run a more frequent EQA scheme is in this clause, and it's to minimize the impact of that potential poor performance and the impact that it'll have on our patients. So what do we want to do? Well, as I've just said, we want to identify issues earlier. We want to take corrective actions earlier, and also then to confirm the effectiveness of corrective actions. So once again, an infrequent EQA scheme, even if we do pick up an error and we put corrective actions into place, how do we confirm the effectiveness of those corrective actions if we have to wait another 3-4 months or even half a year to check that on our next EQA sample? It all comes down, and I've mentioned this word a few times today, our QC strategy. What is the key goal for our EQA, for our internal QC? It's to reliably detect changes in performance that may cause a risk of harm to a patient based on the intended medical use of the results. Okay, we need to detect changes quickly enough to minimize the number of patient results affected. So you can already then imagine an infrequent EQA scheme then about the number of patient samples that may be affected if we have got it wrong. But it's a balance. We need to look at as well to minimize the frequency of false rejections. So a frequent EQA scheme is brilliant, so it is. But then what we have is the number of samples that we're testing. And we need to find a good balance between that frequency and the number of samples, because we want to minimize the frequency of false rejections. We want to minimize these potential errors that aren't really an error in our system. So it's a balance between the frequency, being able to detect the errors, and then what we do with it. So yes, we need to ask then, whenever we look at reducing the risk of harm to a patient, so how likely it is for the failure to occur, that's the probability of that. We need to look at the severity of the potential harm to the patient if the failure goes undetected, and then how reliably our QC strategy can detect the failure if it occurs. If we already say that our internal QC is insufficient, then obviously we need that QC strategy needs to take in our EQA as well, and that needs to be part of this overall process in order to detect then the errors of if we have a failure. So just in addition to that, our laboratory QC is designed to limit the number of erroneous patient results the laboratory reports because of the occurrence of an out-of-control measurement condition. So we ask the question, what is the likelihood that this erroneous result leads to an inappropriate decision or action that causes patient harm, and what is the severity of the harm? Once again, we're looking at a balance here, because not all schemes, not all parameters will be as significant as each other. So the higher the likelihood that an erroneous result will cause patient harm, or the more severe the patient harm, then the more stringent the laboratory should be when identifying an out-of-control condition. Once again, it's a balance. So whenever we're looking at our QC strategy, what is the risk of harm to the patient? And does our EQA, does the frequency of our EQA then manage that risk of harm? And the same for your internal QC. There obviously are consequences for having failure. So the risk of patient safety increases when your QC strategy doesn't detect these out-of-control conditions. Once again, think of the time frame between running your EQA samples. For an out-of-control condition to cause harm, obviously then an erroneous patient results reported and an inappropriate medical decision, action or inaction is made. So once again, looking at frequency, then what is going to happen if we get this wrong? What actions will actually take place? It depends on the parameter, of course, as we've just already discussed. We look at three things here. Did the QC strategy not detect the out-of-control condition? First of all, did we simply not detect it? Or perhaps we detected it, we detected the out-of-control condition sometime after it affected patient results. Once again, this is one aspect we look at for frequency. The response to a QC false rejection causes a delay in reporting results that affected decisions regarding patient management. So I hope you're seeing this here in the consequences of having an infrequent EQA as part of your QC strategy. It does have an important, and it does play, it has an important part to play in this overall process and the strategy that we have. Some other then frequency considerations, just almost quite, not to summarize it yet, but just look at these aspects and just to reiterate them. So first of all, many situations, it's influenced by the purpose of the EQA scheme. i.e. whether it's a snapshot of performance, mainly for regulatory purposes, or is it a review of performance over time? We need to really consider then why we're running EQA and really what we want to get out of it. Sometimes we are just stuck with the availability of samples, and because of the nature of what we're testing and what we want to basically consider, then the sample availability is an aspect. And sometimes we may not run EQA as often as we would like, simply because of the availability of samples. And then, yes, cost considerations. I mentioned this earlier on in the presentation. But it really depends, are they fit for purpose for our QC strategy? And we really need to consider this the whole way through the process. There's lots of things we could have talked about with our EQA today, which we haven't mentioned. And obviously looking at the actual sample as well, the suitability of what we're testing, the commutability of the material that we're testing. Will it actually provide us with a like-for-like comparison to our patient samples? So there's lots of other aspects that we really are not considering here, but we really do whenever we look at how fit for purpose, the fit for purpose of our EQA scheme. So always look at that when we're looking at our overall cost considerations. And this is where I want to jump back to the slides that we already discussed earlier. And I want to mention the North America. As we know, especially for labs who are maybe running some of the CLIA regulated EQA schemes that come out of US, then we know that they tend to have less frequent EQA schemes. They tend to run either every 6 months or every 4 months. So what happens in this situation? Well, what we have found is that a lot of those participants will actually run an additional EQA scheme. And as well as that, actually some of those EQA providers actually offer a more frequent EQA scheme as well, because they're aware that the regulatory type frequency is insufficient. So that's something which we have seen and something which I know does happen with a lot of our own participants, where they're maybe running another EQA scheme, but they also run with RIQAS because of the regular and the frequent then performance assessment that they'll get through that. So I thought I just needed to mention that again at this stage, because it is, as I say, an important aspect and is part of the QC strategy that these labs have. So closely associated with the frequency is also then looking at the number of samples that are tested at any one time. So we tend to have three main types. We have the single sample, we have samples that are repeated then throughout a cycle, and then we have multiple samples, okay, that are measured at one time. This is really what we're looking at here. So we're looking at then a balance. Once again, this word balance, we're looking at a balance between the benefits to the lab having a regular review because of the clauses that we've seen earlier, and also then the workload and the costs that running the EQA will actually have. Will it actually provide an additional benefit running then the additional samples? Of course, the purpose of the EQA scheme will come into this as well. But let's look quite quickly at some of these examples. So let's look at the single sample first of all. So benefits, well, of course, it gives us a lower possibility of mixing up samples, which we have heard multiple times from some of our participants that run these multiple samples at one go, but we'll come back to that in a minute. So it does provide a minimal workload for the lab at any one time. In this case, the samples are truly blind because you're not repeating, but sorry, jumping ahead, I'll mention that just in a moment. The others say it's a balance. It does take a longer time to build up a picture of performance across the concentration range. But if you're running frequent EQA, this is where we're and what we consider would be the best balance. Yes, it might take slightly longer to build that picture up, but it gives that regular assessment of performance over time, which for us and what we believe is the best of the situations. But let's look at some of the others. So where you have, for example, a repeated single sample throughout the cycle. This will then, you will have potentially fewer different lots, different concentrations throughout the cycle. This tends to happen. Especially then if this is part of the EQA scheme and it's known to participants, then this does provide an opportunity for cheating, because once you've run the sample through once, you know what the concentrations are moving forward. So once again, it doesn't give you a good indication of ongoing performance assessment, because it does provide an opportunity for cheating. And even if it is the correct sample which goes through, if you know that you haven't, that you've tested it and it's not giving you quite the correct result, human nature generally means you would tend to run the sample again. And we have situations where we've noticed this. Thirdly, then often offered to provide an assessment of imprecision. And this is the thing, so we're repeating the sample multiple ways through the cycle, and you're trying to get an assessment of imprecision. But as you can imagine, over the course of a year, having maybe the sample repeated 3 times, does that actually give you a true indication of imprecision? It's very unlikely that, and it basically is limited in its ability to do that. That's the function of your internal QC. Lastly, the multiple samples. Well, first of all, you will have an increased workload, obviously, for the lab at any one time. There is, of course, then a higher possibility of entering the result data against the wrong sample. That does tend to be run less frequently, these type of EQA schemes. Not all the time, but they do tend, in a lot of cases, to be run less frequently. And therefore provides less opportunity for then that review of performance and confirmation if the corrective actions have been effective. Lastly, then, more concentrations are covered at a single time frame. That is true. However, if a failure occurs at one level, was this due to a simple random error, or is it actually due to concentration-related bias? And once again, there's more opportunity for false rejections. Is it an actual error? And then if you're only testing again 3 months, 4 months later, once again, you have the same situation. So it's a balance. Certainly what we would think is that regular testing with a minimal sample is the best way to go. But that is our impression. But it's not just what I say is our experience. And this is where I've got 3 examples to show you from our own experience of what we've seen. So this is where we're looking at our clinical chemistry program. And for those of you who know RIQAS, you'll know that we'll provide a bi-weekly scheme. That's a scheme where we're looking at samples every 2 weeks. And also we have a monthly scheme as well, a monthly program. And what we're looking at here is the average performance of 90% of our lab. So we're looking at the general performance of our participants. And if we look at our clinical chemistry, this is what we see. So in the blue is the performance of the months of our bi-weekly participants. And in the orange is the performance of our monthly participants. And as you can see, in general, almost for every single parameter, then the bi-weekly labs perform better than the monthly. Now, it's not to say that we don't have good participating labs running our monthly scheme. We absolutely do. Some of our top labs are running monthly. But overall, what we see is the more frequent you run your EQA, then overall the performance is better. So that's our chemistry. If we look at the same thing for our immunoassay, you'll see basically the same scenario where almost for every single parameter, then the performance is better overall for our bi-weekly participants, labs that are running the scheme more frequently. And lastly is our hematology. And you can guess the same thing is going to happen. As you can see, it does. So it doesn't matter where these labs are. They're all based, all global. They're all spread all throughout the world. It doesn't matter as well how long they've been participating. Really what we've seen the most, or the factor which affects us the most is the frequency. So running frequent EQA, we have found does help for overall performance improvement. And that's one of the, as I say, it's not just us saying, this is the evidence to show that that is the case. So at its best, EQA will then give you laboratory performance over time rather than snapshots. This is what we find. Having regular assessment, really, there's no alternative for it. That's the best way to go. Depending on the scheme, it can provide an assessment of trueness, intra and interlaboratory variation, linearity, identify differences between methods, and monitor continued efforts at harmonization. So EQA has its function, but really what we're looking at here is the QC strategy. Does it actually fulfill all the functions that it's meant to? Because as we've seen, some of the less frequent EQA schemes, you have to ask, does it actually fulfill the requirements that are required for the QC strategy? Last two slides, then. This one is basically looking at the performance improvement. As I've mentioned, our bi-weekly participants overall perform better than our monthly. But within the whole of our EQA assessment that we provide, this is what we've seen. This is based on our target scoring system, which is a simple and unique scoring system for RIQAS. The higher the score, the better the performance. And what we've seen is from labs joining, where we've seen either starting with unacceptable performance, where then they have had significant improvements and they've moved to either then acceptable performance, or even where they were acceptable, where they've now moved to excellent performance. And we've had many, many more situations where we've had smaller increases in performance as well. But this is really just showing you overall the large, the number of cases where we've seen significant improvements of performance. So what we've seen is it does work, and it is a vital and an important aspect, even from the international standards and through accreditation, not only from that aspect, but what we've seen is that it actually does help improve performance overall, and that's what we've seen. So folks, that's the end of my session for today. I'm going to really finish there with, there is one more slide, but it's not loading. There it is there. Yes, we've had 34 years of global EQA provision. We've had lots of experience over that time. Currently, we have just about 76, or actually more than 76,000 participants actually running the scheme. So if you're joining this webinar and you're coming to us first time and you've never really heard of RIQAS, please do let us know. Get in touch if you're interested, and we'd be more than happy to discuss some of these additional features and benefits that we'll have with RIQAS. So, folks, that's me. I'll be happy to take some questions now if you have any. And what I'll do is I'll just stop sharing the screen. So, and we'll jump back in here now. So, are there any questions? Let's have a look. Well, look, if there are no specific questions, please, what I would suggest is certainly this will be still available online. Send us some chats or send us some communication if you have any questions, or if you want to contact us separately, you can at mail@riqas.com, which is our general email account for RIQAS. Or simply, as I say, just contact then your local Randox representative, and I'm sure they'll be happy to discuss this more with you.